Now, it's also claimed that 30% of those with an allergy take medication for it daily. So now we have a new distribution. I mean, I called it Y here because actually Y is mentioned here. And the proportion is now 30% or 0.30. Now, to test this claim, a random sample of n people with allergies is taken. So we have a brand new sample of n number of people. The random variable y represents the number of people in the sample who takes medication for allergies daily. Alright, so guys, so this is pretty much brand new data set here. Okay, so daily. So this is a completely different one. Now, we got a two-tailed test. So this means that the hypothesis to be not equal, or we're gonna look at the left and the right side of the tail at the 1% sameness level. So if it's 1% and we've got two-tailed, we need to half the area. So we need to make it equal on both ends. Okay, and we want to see if the proportion differs from 30%. So that in other words, differs from the proportion of 30%. Okay, not the area. Now the critical region for this test is y equals 0 and y greater equal than w, where 0 is more or less than equals 0 because it's discrete. We begin with 0 onwards. So in other words, this is how it kind of looks like. If you think of it as a normal distribution, even a binomial is all blocks, but just think of it like that. That's the kind of idea we're having. Okay. So what do we want? So find the smallest possible value of n and the corresponding value of w. Okay. All right. So what I did here actually is that because we were given already one value, y equals 0, we could say that, okay, since this is the critical region, this means that we can clearly say that this is less than 0.5% or is somewhere less than 0.5%. So I just said, all right, let probability y equals 0 be the usual binomial formula. So n choose 0, probability of success power 0, failure power n. N C0, anything C0 is always 1, by the way, so that's 1. This is also 1, anything power 0 is 1. Now 70% power n, well, is just 0.70 power n. And this is less than 1% over 2 because it's 2 tails, so 0.005. And now we just solve for n. So what I did is just take logs on both sides, and I got something like this, the natural log, so n drops down, and you get the usual way. And then you divide by ln 0.70 across. Now the reason why it switches sign is because ln 0.70 is a negative number. And when you divide by a negative number, the inequality flips. Okay, so I'll put a little note there over here. And yeah, when you do that, you get n is greater than 14.85. So because it's integer, we're talking about actual number of people, n has to be 15. That's it. Now we plug it in, so we've got n is now, so y is a binomial of 15 and 0.30. Now all we got to do is just use a table and see when the probability, when this critical region here is going to be less than 5%, because we're in that region. We need to find this corresponding w value in the tables. Okay, so let's see this one right now. I got the answer here, but we're going to come back and see why. So for the binomial table, all we care about is from this table n equals 15, check, and probability 0.30. And now we just need to find literally the final 0.005 or 0.5%. Okay, because it's on the right side, we're looking at the final 0.5% before it hits 1. Okay, so that's why I highlight these two values. And yeah, to do that, we first have to notice that this table only records probabilities that are less than or equal to that variable. Yeah, and that's why it looks like this. So probability y less than or equal some value, either 9 or 10, which is greater than 0.995. Now on the table, I found when x is 9, when y is less than or equal 9, you get 0.9963, and this is of course just bigger than 0.995. So that's the perfect value. You can't choose 8 because the value for 8 because it's just below 995. So this doesn't qualify. It's not greater than what we want. So when you choose this value, you could just use the usual probability rule. So if it's y less than or equal 9, you could do 1 minus probability y is greater or equal 10. Remember, we're only concentrating the y greater or equal value, so we can see what w is. And doing that, well, you can get 10. So w is technically 10 here. And just check in when you solve this one and make the probability value the subject, you get 0.037. So yes, that is clearly less than 5%. And that's it. So hence w is 10. Yeah, hopefully the explanation was clear, guys. If you need like any more information on this, just let me know, and yeah, I'll try to try and provide more stuff. Oh man. Okay, let's move on to the next question.